I'm Renaud Delenser and I will briefly present you Placer, that's the tool I'm developing in the Tango H2020 research project. So Placer is a model-based tool. It inputs some high-level model that tells how long task lasts and what is the structure of the task, etc. and with some level of abstraction as for any modeling language. And it finds a mapping, so where do tasks execute and when they have to start in order to minimize some global objective. So the global objective can be the global runtime, the global energy consumption, or both. And concretely, the input is divided into two main parts. We have the model of the software in green on the slide, which is task-based and includes the transmission. And in blue, you have the other input, which is the model of the hardware, including the processing element, such as FPGA or CPU, and the buses. And in red, you have the output, which is the mapping. So where do tasks execute and when do they execute as well? Notice that the mapping also mentions when do transmission occur and on which bus they have to occur in case you have several possible buses. So here you have a more complete specification of Placer. So given the model of the software and the model of the hardware, it finds a mapping and a schedule such that capacities are not exceeded, etc. So the model of the software is sometimes also referred to as the software metadata and includes tasks and transmission. So tasks can have several implementations. That's the interesting part. So Placer will then need to choose which implementation for each task is to be used. Also, implementation can have several targets, so you can have one task with one implementation targeting FPGA and another targeting CPU and the third one targeting FPGA again. That's absolutely possible. Transmission are defined mostly by the data size, so that the transmission duration is computed by the formula you see on the slide, so the throughput multiplied by the data size and the latency. However, throughput and latency are properties of buses. So the model of the hardware, so the hardware metadata includes the processing element, the FPGA and CPU with their own characteristics. Right? Typically, you can define the operating frequency of the CPU, the number of gates and multiplier of the FPGA, etc. Basically, you are free to define any kind of cumulative resource for processor and FPGA, etc. And you have the buses, which define the throughput and latency and also the connectivity. The mapping includes the where do tasks execute, what is the implementation, and what is the timing. Transmission rotate on buses, and you also have the timing. And you have some degree of freedom to express the objective function. Typically, you can minimize the energy, the timing, or both in the multi-objective fashion. This is the technical architecture of Placer. Placer itself is a jar file, so you need the Java environment to run it. It inputs a single JSON file and has some command line parameter, and it generates everything. It's output into a JSON file, and there is no other configuration, etc. to consider here. The input file includes the model of the hardware, the software, the mapping goal, and the additional constraints. The command line defines mostly search parameters such as time limit and the kind of search engine you want to use, search procedure. You can use CP, pure CP or LNS procedure, for instance. And the output is the mapping. So everything is defined in JSON format for simplicity and ease of integration. If you want to know more about Placer, first, where is Placer? Placer is on GitHub. It's open source. It's in the Tango project repository on GitHub. The release file is a big zip file you will find on GitHub as well. It includes a lot of documentation. So you have a reference for the input JSON format, which is quite detailed. You have some command line argument help, which you can have by calling Placer with the help parameter. But basically everything you need to use Placer is included in the zip file. And we're very proud to announce that we've made the beta 2 release in January 2018. And feel free to contact me on the email address here below.